Okay, this is a lecture presentation on the PowerPoint that you'll find on your Moodle relating to H5, section H5. So now we're getting into stairs. So this one will just explain some terminology, a couple different ways we do this, and then there'll be subsequent PowerPoint videos on calculating the math. Okay, so how to build stair systems. Here's just a couple quirky examples for you. So this comes right out of your module. This is something you're going to want to be familiar with, the terminology. So we talk about a stringer, and we talk about laying out your stringer as we move forward in this section. The stringer would be the member of the stairs that gets notched out accordingly to whatever math you determined to be adequate for your building of the stairs. So it gets laid out. So this is typically, depending on the situations, typically 2 by 10, 2 by 12, or something larger like an LVL. So this is the stringer. Here's another term here, the nosing line. Basically, it's an imaginary line that would connect across all the nosings. Okay. Headroom is something that we have to account for, and it ties in with the finished opening. So the headroom is taken from that nosing line, not to be confused with the back end of the tread. Okay, the nosing line to the underside of the floor above. That's how much headroom, and this is a code requirement. For private dwellings, we're looking at 6'4" There's a millimeter conversion that's close to that, 1950, I believe. That would be for private dwellings, and when we get into public, we need some more headroom there. It gets into gets up to 6'8" for the requirement there. I think it's 2050 millimeters is the conversion. So that would be the headroom. And that's something we're going to calculate, what we're going to use to calculate our finished opening of the stairwell. First I want to talk about run and rise. Let's talk about rise first. The total rise of the stair will be from finished floor to finished floor. This is something we have to take into account. So depending on what we're putting up above here, whether it's hardwood flooring, that's 3/4 of an inch, or a thinner material, oftentimes that's not decided yet when we're dealing with our stairs, especially down at the bottom if we're going to a basement. A lot of people don't finish the basement, so that comes in afterwards. So that does affect the rise of the bottom step, but if we know our finishes for top and bottom, we need to use them for our calculation to determine the total rise of the stairs. Total run is exactly what it says it is, the horizontal run of the entire set of stairs, and that comes from the opening to the end of the stairs. So terminology here: rise, run. There's a nosing line. If you can see, we've got a couple triangles here then that's made as a result. The triangle first with what the stairs make, consisting of, if you think of Pythagoras, A, which would be a rise, B would be the run, and C becomes the length along the nosing line. Something we can use to calculate how long of material we need to purchase to make our stringer. And so that's one triangle. I want you also to see here that we also have a triangle that consists of the headroom plus whatever we have for the flooring, for the framing and the flooring. That takes us up to our second floor, and then our finished opening. So there's a triangle there as well. These will come into play as we get into the math on this. We're going to break it down now into individual steps, also from your module, this graphic. Okay, so the triangle we just talked about in the previous slide, large triangle for the total stair, is proportional to an individual step. An individual step consisting of a single run If you can see here, the run is the horizontal distance to the end. Okay, so the run doesn't include the nosing. When we talk about tread depth, it does include the nosing. So if you think of this piece here as the tread, or yeah, as the total tread, that would be the run plus the nosing. The rise would be the total rise for each step, taken from the top of tread to top of tread. And if you took these treads away, that rise would be identical on the stringer as well. Here we get into the nosing. There's the nosing right there. In this picture, they show a stringer support board, often used to, basically you would fasten this way into the stringer. There'd be several stringers along that line. You'll see as we move forward. And then you would fasten into the framing members there. Often this is a piece of plywood, something like that. So talking about stringers, a couple ways to do that. They can be cut out. Like we see here, say that was a 2x10, 2x12. We used a rise and a run on our framing square. It gives us these lines that eventually get cut out, and then we have the stair stringer. Here we have some metal stringers pre-made. Other ways to do that. Dadoed we have here. This comes out of the book. And it's basically just a notch that we would cut into a solid material, and we would be slipping the treads into that. Pleated is just basically having something to sit the stairs or the treads on. Here we have a visual of a housed stringer. This has all been similar to dadoed, and by the riser and the tread would slip in there. Not very common anymore. And here we have a cutout stringer, basically one that has been cut out and next to something that hasn't been cut out. You'll find this graphic in your book. Gets into the terminology involved with handrail systems. Good for you to become familiar with some of this. A lot of it is redundant. Let's see if I can pick out the most important parts. So newels are these vertical members that exist at different locations. Those are the structural members of a handrail system, newel posts. What else do I want to pick out here? Let's see. Well, we have the handrail. We have the balusters, which are basically the vertical members in between the newels. Here's baluster right here. Okay, this is something you can look over on your own. It's not, I don't think it's the most important point of this section, but it's good for you to know some of these basic terms. They talk about a couple different types of stairwells. Again, this is, in first year, this isn't as relevant, but as you get into the later years in your apprenticeship, you'll have to figure out how to calculate the rise and run for each section in total for these different types of shapes of stairs. For the most part, in first year, we deal with the straight stair. So it's a single shot, just to introduce you to it. And then briefly, we talk about quarter turn stairs with winders. These would be the winders. You've probably all seen these. They did introduce some stricter code requirements for these within the last decade. Basically, because of the danger if you're walking on the inside of the stairs, there's just not enough tread there for a foot to land with this style here. Let's see. This is something you would do if you were tight on space and needed to make that turn rather than just having a landing. Okay. There's a quick little blurb here. The maximum total rise for a flight of stairs is 3.7 meters before you need to break that single run with a landing. Okay, and that does it for this PowerPoint. It's just a brief introduction, and we'll get into the math in the next video.